This behind me is a mobile robot with bimanual arms that we're investigating for embodied AI research that is residing here at Brookhaven. And this is the first of, we hope, many robots that are going to be part of this robotic platform and this robotic program, which we call SEAL, the Scientific Embodied Agents Lab. What we're studying here is the frontier of AI capabilities for driving robots to help with scientific experiments, to help with workflow automation, and to help with operations at the lab. There are already many cases of robotic automation that are addressable with a single arm doing what we call a pick-and-place operation. Pick up an object from a known location, place it somewhere else where the configuration of the source and the target locations are well understood. It's not an easy problem to solve that, but it is addressable. Whereas complex manipulation, dexterous manipulation, that involves two hands. In this case, they're grippers, not actually hands. But that is much more complex, much more dynamic, and requires significantly more innovation on the algorithmic side. Embodied AI takes the perspective that the robot is just the body for an AI agent. It is a way for an agent to perceive and act upon the world. And that perspective gives us a lot of the advantages that we can leverage from the tremendous acceleration of AI research in the last few years. We are taking an AI-first perspective rather than tackling all of the many different challenges that robotics research lends to this field. We're looking at the AI. And the robot is just the embodiment. So we're looking at the algorithms. Particularly, we're interested in foundation models, vision language action models, reinforcement learning, world models. A lot of the strategies that are starting to become prevalent in the AI community and that have some reach into the robotics community, we want to apply those to hard problems in domain sciences. We need to have the data that is necessary to train the AI algorithms, the AI models that we want to deploy on these robotic platforms. And the platform that we have selected here is designed exactly to suit that need. It actually has 4 robotic arms. And the 2 rear arms are controllable by a person, and the front arms are followers. They are local teleoperation. And this allows you to collect data very fast. Whereas alternate solutions might require manual programming of each of the individual samples, of each individual trial runs that you want the robots to be using for data collection and for training. Here, we can collect data very quickly and then use a data-driven approach to train the algorithms that we want the model to learn. This lab is established with the ambition of becoming a testbed. We are very interested in partnering both within and beyond Brookhaven. We want this to be a place where people can come and look at their research problems and their research opportunities that can be addressed with robotics, with automation, with AI together. We're interested in those problems that are not yet addressable, things at the frontier, things a little bit over the horizon. And this is a place where people can bring a snippet of their problem, a kind of a sample of the opportunity that they're interested in pursuing, and test them here in the lab with our various robotic platforms. We are developing an integrated robotic strategy for the lab, and that covers robotics and embodied AI. We want to pursue this research, the robotics and embodied AI research that addresses the mission needs of the entire laboratory and all of the scientific directorates within the laboratory. And then beyond the lab, we're interested in pursuing an embodied AI alliance that's going to bring in industry and academic partners so that everybody can bring their technologies to the table to pursue robotics and AI for scientific discovery.